everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on Ohm's law, Kirchhoff laws, Kirchhoff voltage law and Kirchhoff current law and source transformation technique. Now here in the first topic is here Ohm's law limitations. Next Kirchhoff voltage law and Kirchhoff current law. And next, current division rule and voltage division rule in the electrical circuits. And next, source transformation technique from the voltage source to the current source and current source to the voltage source. So now here the first law is here. Total we have 3 laws in the electrical circuits, basic laws. First one is Ohm's law, second one is the KVL, Kirchhoff voltage law and Kirchhoff current law. Now here Ohm's law statement here, we know very well this law. First one, voltage across any element is directly proportional to the current. So now here it states that at constant temperature in an electrical circuit, current flowing through the element is directly proportional to the potential difference. That means voltage applied. So V is directly proportional to the I. So if suppose this is the one element, that is resistance, this is the current flowing to the element and this one is the resistance, and voltage across this one is plus and minus. So now this current parameter, this current is directly proportional to this V. Now here current is directly proportional to the VR, V is directly proportional to the I, V is equal to IR. Here R is the proportionality constant and R equals to rho L by A or V by I. So now here R is rho means specific resistivity and L is the length of the conductor and A is the cross-sectional area of the conductor. So now what are the limitations? So there are certain limitations for this Ohm's law. It can be applicable only for metallic conductors such as copper and silvers. So now second limitation, this is important, it is not applicable to all electrical circuit elements. So now here for semiconductor devices, diodes, so semiconductor device and transistors, it is not applicable. So now here if you draw the graph here, so it should be straight line passing through the origin, the voltage current relation. If you draw the characteristics of any element, voltage current characteristics, this is the voltage and this one is the current. So if you draw the graph between these two, so this is a straight line. So this is for ohmic conductor, so this is the non-ohmic conductors. So now here, so now we know very well this one. So this is V is directly proportional to the I, V is equal to IR. So now I equals to V by R. So now here this I equals to V by R. So this is okay. And V is equal to I into R. This one is okay. And R equals to V by I. R equals to V by I. So R equals to V by I, this one is okay, and I equals to V by R and V is equal to IR. So now here another one here, this is important here. So now here this is the current and this one is the resistance and this one is the power and this one is the voltage. So first V is equal to IR, we know very well this V is equal to IR, this one. So according to the Ohm's law, so first here V is equal to IR, V is equal to I into R and P equals to V into I, we know very well this one. So now here P equals to, how now here this this voltage equals to, this voltage formula equals to V equals to P by I. So this one V equals to P by I, and next this one equals to this voltage equals to P by I. Now here what about this one? So now here this one equals to this V equals to P by I, means here you can write this one. So now here I square R or V square by R. So now here next here P equals to V into I. P equals to V into I. So P equals to V into I, this one is okay. And so V equals to IR means into I. So that equals to I square R. This one is okay. Now, so now here I equals to V by R. So now P equals to V into I means, so V by R that equals to V square by R. Is this okay? Now, here R equals to, so now what about the current? Current equals to V by I. So current equals to V by, sorry, this R equals, sorry, this current equals to V by R. This one is okay. And next thing here, this current equals to, here, this current equals to P by V, current equals to P equals to V into I means current equals to P by V. This one is okay. And next here, this one, I square R. P equals to I square into R. I square into R means I equals to P by I R into square root. This one. Is this okay? And next thing, R equals to V by I. This one. R equals to V by I. Is this one is okay? And next, P equals to I V square by R, that equals to P into R equals to V square by P. This one is okay. And same thing here, P into R that equals to V square, and P into R equals, that equals to V square, and V equals square into P into R. This one. This V equals to. And next here, P equals to I square R and R equals to P by I square. This one. So now here this is for voltage, current, power and resistance, all the parameters formulas. So if you know the P equals to I, V is equal to IR and P equals to V into I. If you know this one, and then you can write any formula for this. And next, Kirchhoff laws. So here we have two laws, Kirchhoff voltage law and Kirchhoff current law. What is meant by Kirchhoff voltage law? Let me change the color over here. Kirchhoff voltage law means algebraic sum of total voltages in a loop equals to 0. So now if you see the statement, it states that algebraic sum of all voltages in a loop must be 0. So in any closed path, in that elements all if you add all the voltages, rising voltages and dropping voltages, EMFs and voltage drops, so that summation, algebraic summation, so that plus and minus should be 0. So now in other words, in any closed path, in any closed network, the total voltage around the loop equals to sum of the voltage drops in the same loop, which is also 0. So the ideal key by Kirchhoff law is known as the conservation of the energy. So now here this is one circuit. So now in this circuit, so how many elements here? So how many elements here? Total number of elements 1, 2, 3 and 4. 4 elements means here K equals to 1 to 4 here. So N here N equals to 4. Now N is total number of elements in the loop. So now here this is algebraic sum of total voltages in a loop equals to 0. So this algebraic sum K equals to 1 to N. N is the number of elements in the loop. K is the kth element voltage. If you apply KVL, algebraic sum of all voltages must be 0. So now here this voltage across this one is VAB. So this voltage is VAB, R1 voltage, and this voltage is VBC, and this voltage is VDC, and this voltage is VDA. So VAB plus VBC plus VCD plus VDA. So now here this is minus. Why here it is minus? This is the voltage source, rising voltage. So now if current flows from plus to minus, and this is minus to plus. If you take for plus to minus, take positive sign, and this is the minus to plus, take minus. So this is a minus. And now here VAB, rising voltage is equals to summation of dropping voltage VAB plus VBC plus VDA. So now here the voltage source from D to A is this is negative due to the flow of current from positive to negative, negative to positive. So now here if you take one examples, determine the current flowing through the each resistor and each voltage resistor voltage across the 100 ohms, voltage across the 150 ohms and voltage across the 220 ohms. How we will calculate this one? So now here using KVL we can determine the current, this current flowing through this each resistor and this current. So this current is I. So now here how we will calculate this one? So now here this current equals to, if you apply KVL, so minus 10 minus 100 I1. So this is rising voltage and this is dropping voltage 100 into I1 if you apply KVL in this loop, and minus 150 I1 minus 220 I. So same current flows to the each element in the circuit. So first one is here 100 ohms resistor current, 150 ohms resistor current and 220 ohms resistor current is same. So in series circuits, in the series circuit, same current flows through the each element. So same current is I and I. So all currents must be same. Now here this current equals to 10 by 100 plus 150 plus and next 220 volts. So now this current equals to 0.0. This current equals to 0.021. So that means 21 milliamperes. So now here this case and next case here. So voltage across the 100 ohms resistor. Voltage across the 100 ohms resistor V is equal to IR. So what about the current? This current equals voltage across the current equals this one equals to V100 equals to I current flowing through this one. This current equals to already this one, this into 100. V is equal to IR. So 0.021 into 100, that value is 2.17. So 2.217 this value. And next thing here, I into 150, that value equals to 3.19. And this one I into 220 volts, that equals to 4.68. So now here you can verify the KVL is also algebraic sum of total voltages n equals to 0. If you apply 10 volts here, so 2.1 plus and next 3.19 plus and 4.68. So if you add this, you will get the approximate 9.98. Almost same this voltage. And next thing here, if you take the another example here, this is the one circuit. So this is one circuit. This is one circuit. This is one circuit. So for this circuit, so now here in this, so now this voltage is around 30 volts and this one is a 2 volts and this one is a 5 volts, and find out this V1 voltage, and this is the 3 volts and this one is a 4 volts. This one is a 4 volts. And what about this voltage V2? So determine the V1 and V2 using KVL. So now if you apply KVL in this loop, let me change the color over here. If you apply KVL in this loop, so first here minus 30 plus 2 volts plus V1, this is R1, R2, R3, R4, R5 and R6, plus minus and plus minus and plus minus plus minus plus minus. So minus 30, if you apply KVL in this loop, algebraic sum of total voltages in a loop equals 0, plus V1 and plus 5 volts equals to 0. So now here, so minus 30 plus 2 plus 5, so minus 23 plus V1 equals 0 and V1 equals to 23 volts. So this voltage is here, 23 volts. And next same thing here, if you apply KVL in the second loop, algebraic sum of total voltages in a loop equals to 0. This voltage equals to 23 equals to, so 23 volts, so minus 23 volts plus 3 volts and plus V2 plus 4 volts equals to 0. Minus 23 plus 3 20 and next 16 V2 equals to 16 volts. Here V1 equals 23 volts and V2 equals to 16 volts. So now here second law is here in the KVLs, that is in the Kirchhoff laws, that is Kirchhoff current law. So now here, so first thing here, sum of entering currents equals to or sum of leaving currents or algebraic sum of currents at a node equals to 0. So now here it states that algebraic sum of currents at a node must be 0. In the previous one, Kirchhoff voltage law, algebraic sum of voltages in a loop equals to 0. But here in place of loop there is a node, here in place of currents there is a voltage. So in other words, the current or charge entering the junction is exactly to the charge leaving the node as it is. So now here it is also known as the conservation of charge. Now here this is one circuit. So now here this is I1, this is I2, this is I3, this is I4 and this one I5. Here algebraic sum of currents at a node equals to 0. So algebraic sum of currents at a node equals to sigma Ik equals to 1 to n. Here number of elements connected to the node. How many elements connected to this node? Here 5 number of elements connected to the node and K is the kth element current. So now here what are the entering currents? If it is entering current, is sum of leaving currents plus sum of entering currents equals to 0. So now here leaving currents we are representing minus and entering currents we are representing with positive sign. So what are the entering currents? I1, I2 and I3 are entering currents. And next here I1, I2 and I3 are entering currents, that is positive sign, and I2 and I4 and I5 are leaving currents, that is negative sign. So now here sum of entering currents equals to sum of leaving currents. I1 plus I2 plus I3 equals to I4 plus I5. So now here at a node, from this statement we can conclude that sum of entering currents equals all sum of entering currents equals to sum of all leaving currents. Sum of entering currents equals sum of leaving currents. This is important. So now here next case. So now here this is the one problem. So now here this is one problem here. So first problem here in the KCL. So now here this is circuit 1, circuit current flowing through the each resistor. So this is our laboratory circuit, current flowing through the each resistor, current flowing through the 150 ohms and current flowing through the 220 ohms, and this is current flowing through the 100 ohms resistor. How we will calculate it? So first calculate the equivalent resistance for this one. So this one, so 150 and 220 are connected in parallel and again in series with the 100. Again in series with the 100, that equivalent resistance is 1891. So now here this current flow to the 100 ohms resistor equals to this 100 ohms divided by this this 10 volts divided by this R equivalent V by R. This current equals to 0.052. So next here, so now this current flow into the 100 ohms resistor is 0.052. So next, what about the current flow into the 150 ohms? If you apply current division rule, so that current division rule means total current, this is total current, and opposite branch resistance. Opposite branch resistance for this one 220 and total resistance 150 plus 200, that value is 0.03 and that means 30.9 milliamps. This one is 52 milliamps. So next, what about this one? Next, opposite branch resistance was this 220 ohms resistor and 150 by 220 plus 150. This is the total current. So this value is that equals to 21.0 milliamps. If you add this one, so you will get the same value, this 52 milliamps. So now here, if you, this is entering current, these two currents are leaving currents. So for this case here, 52 milliamps plus 30 milliamps plus 21 milliamps, so that is around 30.9 minutes. That is it is satisfying KCL if you apply KCL at this node here. So now here next problem here, source transformation technique. So in the source transformation technique, first here in the source transformation technique, so first voltage source in series with resistance, this one. This is the voltage. Suppose in the circuit there is a voltage source in the resistance. This one is voltage source and this one is the resistance. If they are connected in series, such type of circuit can be replaced by same thing here. And this one, current source in parallel with resistance. This is source transformation technique. So now here from the current source in parallel with resistance, so this is also can be replaced by current voltage source in series with resistance. So now this voltage source Vs equals to I into Is into R, and this current source value equals to Vs by Rs. So now here, so now this is the current source and this one is the voltage source. So now here this remaining circuit is same for both the circuit. And next, those Vs equals to Is into Rs and Is equals to Vs by Rs. And voltage division rule. So what about the voltage division rule? So this is the supply voltage V1, R1, R2 and R3 are connected in series, and the whole circuit is connected across the supply voltage is V. So now here voltage VR1 and VR2 and VR3. So this individual resistive voltage currents voltages are here, same current flows to the each element Is, and this one R1 and this Is equals to this R1 divided by this one. So now here R equivalent equals to 3 resistors are connected in series, means that is R1 plus R2 plus R3 here. So now here this is R3. So now here this is RT. So this one, this R1 divided by this R1, this VR1 equals to R1 divided by RT into IT, and same way here RT by this is R equivalent. This R equivalent is this one. This is R3 and RT. So these are the voltage division rule for this series circuit. So now here Is equals to this current equals to this voltage divided by this resistance. Next, current division rule for the parallel circuit if two resistors are connected in parallel. So voltage division rule for two or three resistors are connected in series, and current division rule for parallel circuits only. Two resistors R1 and R2 are connected in series, and I1 is current flowing to the R1 and I2 is current flowing to the R2, and Is is the total voltage and Vs is this one. So now here in this case, first one, we need I1 and I2 if you know the Is and R1 and R2. So how we will calculate this one? Total current into opposite branch resistance. This I1 current equals to opposite branch resistance divided by total resistance R1 plus R2, and this I2 equals to Is by opposite branch resistance R1 divided by R1 plus R2. So now here this is the formula, and this I1 equals to Vs by R1, same voltage, and this I2 equals to Vs by R2. Next, open circuit and short circuit. So we know, these are two important definitions. So this is the wire and this one is the air. So now here open circuit resistance is 0. Sorry, short circuit resistance is 0 and open circuit resistance is 0, infinity. And short circuit open circuit current, short circuit resistance is high amount of current, and this one is current is 0. And next open circuit current is 0, and open circuit voltage we can measure. Short circuit voltage is 0, and open circuit voltage we can measure. So this one. So now here R equals to 0. No voltage difference exists all the point on the wire at the same point, and current flowing through can be determined. So here we can determine the current. Here voltage difference there is exists, then we can measure that one. We can determine that one. So now here I hope all the concepts are clear to Kirchhoff voltage law, Kirchhoff current law, Ohm's law, and next voltage division rule, current division rule, and next source transformation technique from the voltage source to the current source and current source to the voltage source. Next, open circuit and short circuit. Short circuit means that is wire, and open circuit means there is no element between the terminals, and that is open circuit. So I hope all these concepts are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you.
Like, share and subscribe. Hit the bell icon for more updates.